Hi, my name is Hannah Okacha and this is my chemical reaction investigation. What is this project about? We were assigned a chemical reaction. The goal of the lab was to calculate the amount of each substance to use and find how much of it actually reacted during the experiment. What is a chemical reaction? By classifying chemical reactions, you can more easily predict what products are likely to form. There are 5 general types of chemical reactions. Combustion. Campfire, candle, barbecue grill are all examples of where combustion can take place. A combustion reaction is a chemical change in which an element or a compound reacts with oxygen, often producing energy in the form of light and heat. Synthesis. It's a chemical change in which two or more substances react to form a single new substance. Decombustion. It's a chemical change in which a single compound breaks down into two or more simpler products. The products can be any combination of element and compound. A single, a single replacement reaction is a chemical change in which one element replaces a second element in a compound. You can identify a single replacement reaction by noting that both reactants and products consist of an element and a compound. A double replacement reaction is a chemical change involving an exchange of positive ions between two compounds. The procedure that you will need for this lab is the first step to find all the materials needed for the experiment, which are safety goggles, a glass disc, a scale, magnesium, Bunsen burner, and tongs. Once you have all these materials, you start off by getting the weight of the glass. Afterwards, you get the weight of the magnesium. Then turn on the Bunsen burner. Using the tongs, hold the magnesium ribbon on top of the flame and hold it there until the reaction happens. Then place the reactant magnesium on the glass disc and weigh it. This allows us to get all the data values necessary. The balance equation for this lab is the balance equation goes from both oxygen and magnesium stress reactants, and the product part of the equation is the result of which the magnesium iodide. The chemical reaction for us for magnesium and oxygen was chemical reaction of synthesis. It was synthesis due to the fact that two or more substances, oxygen and magnesium, reacted making a signal substance, magnesium oxide. The claim for this procedure is the atoms and therefore mass are conserved during a chemical reaction. Matter cannot be created or destroyed, which means that it is always conserved. No mass was lost or gained during this reaction, which is a law of conservation. The reactants consist of two oxygens and magnesiums and end with the same amount. The BCA table shows that magnesium used was conserved, but we cannot measure the oxygen levels in the air. We had to find the right amount of moles to use by its atomic weight to get the closest answer we could. By doing this math and adding the reactant weight, we saw that our answer was 48.702. This is the math that we did to find the weight of the moles at the end. The model represented shows that the process of the reaction occurring in the experiment as energy in the form of heat warms up the magnesium ribbon, oxygen molecules in the air begin to react with the magnesium, causing it to glow and forms magnesium oxides. The product made was magnesium oxide 2MgO. The matter was conserved throughout the reaction, and as we started with 2 plus 2 coming from 2 magnesium molecules and 2 oxygen molecules, then the right hand side there is 2MgO being distributed, making it once again 2 plus 2, proving that energy was conserved. We had to be very careful with this experiment, which means that there are several things that could have gone wrong. Our calculations was a main part of it. Our calculations that we did for the BCA table could have been incorrect if we didn't use the exact measurements and if we miscalculated. The surrounding of each test we also counts. At the end of the experiment, we added water to the magnesium because it was burning from the fire and to make the magnesium oxide stick together as a powder. Adding water made the weight of the mass at the end almost double the projected weight. This could have happened because maybe not all of the water evaporated under the fire, which means that it added weight to magnesium oxide. Thank you.